sense out of this. Who would like to begin telling me how a battery works? A voltaic cell. What's happening on the particulate level? Carolina, you want to start off? Oh, come on.
You
I
can
barely
tell.
understand it.
Of course, we're all just learning, right? Seriously, I mean, we wouldn't be studying this if we all knew. So let's let Carolina just get us started, and then we'll jump in on other people. Now, you can share one thing that you've noticed about how this works, and then I promise I'll move on.
You can do it.
What do you want me to say?
So, what does the first question ask you?
To describe what happens in the reaction.
Okay, so what did you think as you
I
went through?
think. I'm not
Okay.
sure.
Okay, of course.
That zinc is losing electrons, and that copper is gaining.
Okay.
Okay, so thank you. So Carolina starts us off, and what did you see that made you think that?
So
The little.
it's almost transferring.
Okay, so you saw the zinc lose electrons, and then what happened to the electrons that the zinc lost?
They mix.
What did they do?
They went into.
Did they go into the solution? Well, let's look.
Wait, the electron?
Let's watch, Carolina,
Yes.
and everyone else. Hold on just a second. Here we go, back to the beginning, all right? So Carolina's told us the zinc loses electrons. Now,
I think copper.
here are the electrons, they're going. Where are they going? Through the wire, right? They turn this propeller, and then they do what? What happens next, Eric?
They're absorbed by the copper ions.
Okay, they're absorbed by the copper ions, which does what?
Is it making an ion or what?
Oh,
Okay, so this is a good question. So, are we making an ion when we do this?
yes.
Or are you making a compound?
We're making an iron and an element.
An ion of zinc.
Alright, we made an ion of zinc, Eric says. Did we make an ion of zinc here?
No, zinc.
Yeah.
Sulfate.
Okay, so you're right, Alejandra. What's missing from this drawing? Sulfate. And actually, that's going to get at something that's very important. Because the sulfate is present. What do we say that sulfate is in this reaction?
Spectator.
It's a spectator.
Is it the
So
oxidation agent?
It's not participating in the reaction, but it is very important. And of course, it has to be there. You can't have only positive ions, right?
Okay, yeah.
Okay, so, Mohammed, can you summarize what we just said then about how the voltaic cell works?
Oh, okay. So, from like the reaction, like more zinc ions, zinc sulfate ions, like are produced. So the zinc in that case will like lose 2 electrons.
Okay,
Because it goes from zinc with no charge to zinc with +2. So the two, like the electrons like are moved to the copper. So the copper, so some of the copper like gains 2 electrons, which will make it solid.
okay, and do we see that,
Wait, what's going to become solid?
Copper.
what becomes solid here?
Is it copper already solid though?
Yeah.
Yeah.
But-
What?
But there's
What-
more.
Okay, Mohammed, do you want to refine, do you want to say more about your answer? What do you mean when you say that copper becomes solid?
So like,
Oh, I
so
get
like
it.
they were like copper with like 2+ charges, and
Which we call copper,
it's ions.
right, copper ions. Are they solid, Benji, at the beginning? The copper
I thought he
ions?
meant like the thing, like the physical, like
The strip.
copper. Yeah, the strip.
Okay, is it,
I know. I got what he meant about the copper being solid. Like it's like it's not an ion anymore. It's like an element now.
okay, right, so that's what's happening to the copper in this case. That's the reaction that's occurring.
Would you
The copper that is present as ions is becoming copper in the form of a metal, right? Yep, an element because it has no charge, because it has gained 2 electrons. Yes, Hector.
Why is it that it's not happening the other way around?
Ah, that is such a great question, and it's exactly what this whole unit is about. Why is the zinc turning into ions and the copper ions turning into copper metal? Why isn't this running in reverse?
Is the copper already an ion?
Well, that's a good point, Eric.
Because
At plot,
zinc gets oxidized.
But why?
All right, yeah, but why?
Yeah, we'll have
The zinc, what makes, you're right, Alejandra, but I think Hector's question is, why does the zinc get to get oxidized and the copper ions get to get reduced?
because both
Reacting
elements have the
ions
same
have
charge, both ions have the same charge. Why is it that it's not happening the other way around?
And you will be able to tell me that answer very soon, like within a day or 2. Why exactly that is. And I'm going to come back to you and I'm going to ask you to summarize it for us. Yes?
Can you summarize what happened again?
Yes.
They're
All right,
right next to each other in the periodic
So
table.
I'd like to summarize, and then I want to identify the anode and the cathode, because those are important to know on the periodic, on the vocabulary end. Okay, can we watch this? And I will explain exactly, I'll summarize our discussion here. So when we start off, we have an atom of zinc metal here. Okay, it's neutral, so it has an equal number of protons and neutrons. This atom is going to lose 2 electrons. And those electrons are going to travel through the wire. And as they travel, moving electrons are electricity. That's all electricity is just moving electrons. So the electrons move, and that electricity can be converted into lighting a light bulb, into light energy, can be converted into mechanical energy by running a fan or a propeller. And it turns this propeller, and the electrons then travel to the copper, where this cannot be negatively charged without attracting the copper ions that are present. So a copper ion is attracted here by the negative charge of the newly arriving electrons. Those electrons reduce the copper ion, which makes it go from aqueous to solid. Okay? And so which one of these metals is the anode?
Zinc.
Because it is being
Oxidized.
oxidized. And which one is the cathode?
Copper.
Copper. Do you guys have a hypothesis about the mass?
I have a question.
Yes.
So are we making a solid on that side?
Are we producing, what do people think? Are we producing solid on the copper side?
Yeah.
But then again, I thought it was just electricity. And does electricity have mass?
It doesn't. Is it when it supplies electrons? Do these ions weigh a different amount than this? No. What happens to the weight of this solution?
Stays the same, right?
Does it?
I
The
think it gains.
solution?
It's
Hold on for just a second, folks. So what do we think is happening to the mass of the copper strip?
It's gaining mass. Because it gains.
It's gaining mass. But that mass already exists in the form of the ions.
Well, yes, but the strip is.
The strip, right, but the ions are not part of the strip at the beginning.
Yeah.
So when they become solid and join with the strip, what do you think?
Mass.
Gains mass.
That's right.
Yes, I knew it!
We'll see tomorrow.